How about if you have one type and you want to change it from, for instance, the integer type, you want to change it from an integer to a floating point. How do you do that? How do you do that? I have an integer variable. I want to change it to a floating point, or I have a floating point. I want to change it into an integer. One way or the other, okay, if your expression is a mixed type where it involves the floating point, you are going to have a floating point result. How about you want the integral result, or you want an integer? You would need to cast or convert that type into the type that you want. Here we call it casting. Casting, that is explicitly changing the type of one data to another. Okay, and the syntax is as simple as this. You have static underscore cast, the data type name, and then the expression. So for instance, we want to cast 25, which is an integral value, to double. All we need to do is to say static underscore cast, and then angle bracket, we say we want to cast it to double, and then we put our expression in it. Okay, for instance, you also have an integral, you have a floating point expression here, which is 7.9. You want to cast it to an integer. All you do is static cast integer, and then the expression follows. Now let's try some few ones here. So casting, okay, casting. So here we have cout static, okay, casting 10 to floating point will be static underscore cast bracket open double close and then 10. Now we can evaluate the expression and we're going to have 10.0. Now the reason why we have casted a 10 alright floating point, but yet we are seeing 10 only. This is something I want to draw your attention to, because 10.0 automatically is still the same as 10. The compiler chooses to make it 10. However, there is a way we can manipulate so that we can say that show this number of decimal places. Okay, show this number of decimal places. Now let's make this one 10 point. Let's make this one, this is already double, but when this is already integral, but then when we casted it, we had 10 instead of 10.0. Now this is what is going to happen. We can manipulate the number of decimal places that the compiler should display. Now in order for us to manipulate, we need to include another directive, io_manip, okay, io_manip. So what we can say is, before we print out the 10, which is now double, we want you to be able to fix the 0, or to fix the decimal point, even if it is 0. Fix it. So when we run this, then we can get the 10.00000. Now this tells you that now our 10 is no more integral, but it is now a double. It is now double. Now there is also another way in which you can control the number of precision that you will have after the decimal point. Now the way that we do that is to call the set precision. So we say that cout set precision, let's say 2, and then as soon as we do that, we are going to have 10.00. Now let us say that you have a variable, let me declare a variable here, say double data equals to 5.44456. Let's say 7. Yes, you have this variable and you want to print it out, cout data, and then when you print it out, you're going to get 5.46. Now, the reason you are seeing 5.46 where the 5 here has been run up to the nearest integer, which is from 5 to 6 because of the 6 here, is because of the set precision that we're using here. Now, let's say that we increase the precision to 5 and then we print it again. What is going to happen is as soon as the compiler executes the set precision 5, it has to leave 5 decimal places, and therefore when we run, we are going to get 1, 2, 3, 4, 5, so 7.0. So if we say we're going to leave 3 decimal places, then we can leave 3 in the set precision, and then when we run it, we are going to get 3 decimal places, and therefore the 4, 5, 6 here, the 6 has become 7. And these are some of the ways you can manipulate how the compiler prints out double data, or the double data type, or floating point data type. Okay, so let's say that now we want to cast the data here to an integral type. Let's see what we are going to have. So here we say cout after casting data. After casting data is, and then we say static underscore double, and then we put data in, and then we end the expression, and there is what we're going to have. So after casting, data is, we want to change it to integer, so integer, and then we run it, and that's what we're going to have, 5. So you realize that the data which was floating point having 5.4567, after the point, everything has been truncated, have been cut off for you to have an integral data type. So this is what casting does to our data type. So we can cast from one type to another, and this type of casting that we have stated here is what we call explicit type conversion. Okay, so now we have learned how to cast. Now, one of the things that you always have to look out for to be able to understand certain algorithms or statements that have been written in C++ is for you to be able to understand the syntax. Okay, remember, it is the rule that governs that programming language. And if you see something like this, that in order for you to cast from one data type to another, you have the static underscore cast, the data type name, and bring your expression here. So that means we can even have something like this. That let's perform 25.2 times 3.8 and say that whatever happens, we want times 3.8. We can say that whatever happens, we want the value in integral type. So int, and then we put this data into bracket, and we end the statement. And then when you run it, instead of having some decimal places, you're having an integral type. So this can also be another computation that has to be done to get a result. Okay, so not just only the variable that is holding the data, but you can put an expression here. Yes, you can put an expression there. All right.